All right, so we're going to continue on with storage on Server 2016 that we started last session. And obviously, last session we talked about the traditional server storage as far as RAID, okay, redundant array of independent disks that helped us protect our data in case of outages. So we knew that if we had RAID 1 or RAID 5, which is actually supported by Server 2016 as a software RAID level, that if one of the hard drive fails, our data and our system is actually protected. And that's the main thing, the ability to keep on going in the event of failures. But let's actually talk about some more storage options for Server 2016. So today we're going to look at storage spaces, work folders, shadow copies, the idea of data deduplication, and the idea of storage pools. So now we're going beyond just those RAID levels. Okay, those RAID levels have been around for years and years. So storage spaces is pretty new. Okay, it's like we've been talking about SANs and so forth. Okay, how we have storage servers that actually make up a SAN and then allows other servers or computers to use their storage almost like local disks. Well, storage spaces pretty much possibly turns our Server 2016 into one of those storage servers. Okay, so if you look at this little diagram here, which actually specifies that we have physical disks, storage pools, virtual disks, and disk drives. So if you look at this, guys, physical disks, they're the things you actually can touch. Okay, they're the things that you can actually go to the store and buy. But if you look at the disk drive itself, it's not directly on the physical disk anymore. Well, it is eventually. Obviously, the data has to be stored somewhere, but it really removes the linkage between the disk drive that you can access and use and store data and the actual physical disks. Okay, if you like to think of it, the physical disks is the hardware. Then out of this hardware, all the storage spaces out of these physical disks, we create what's called storage pools. Okay, which actually pulls together all the different storage capacities of the disks and makes them available. Out of this storage pool, we create what's called virtual disks. Okay, so virtual disks, and then in those virtual disks, then we create the drives or volumes. Okay, if you like to think of it, in the old days, it used to be that we create the drives and volumes directly onto the physical disk. Okay, but when we do that, we're actually limited by what the physical disk is. Okay, the capacity of that physical disk. That if that particular physical disk is damaged or has errors on it, then it affects our drives directly. Whereas by using the storage spaces where we're disconnecting the drives or volumes from the actual physical disk, they're not actually created on the physical disk. They're created on a virtual disk that's created out of the space that's in the storage pools, which is then using the actual physical disk somehow. Okay, so storage spaces uses storage spaces to add physical hard drives or disks of any type, any size to a storage pool. Okay, and then we can create highly available virtual disks from the storage pool. Highly available means that obviously, just like we were talking about before, if there is a failure, then it doesn't take our server down, or we don't lose our data. It's highly available, so it's very redundant. So to create a virtual disk, you need to do the following. You need to have at least one or more physical disks. We then create a storage pool that includes the disks. Then out of that pool, we create virtual disks that are created with the disks from the storage pool. And then in the virtual disk, we create disk drives that are based on the virtual drives. Virtual disks are not virtual hard disks. They should be considered a drive in Disk Manager. So in the last lesson, we talked about using Disk Manager to actually create all those volumes, deleting volumes, creating RAID volumes, creating span volumes and such. But they are working at this level, the Disk Manager, working between the virtual disk and the disk drives. But obviously, in last session, there was no such thing as virtual disk. It was directly creating disk drives on the physical disk. But what we're saying is that now the next level is where we actually sort of take our physical disks and add these two extra layers. how we deal with these disks afterwards in Drive Manager is just like we would deal with the physical disk, but in fact these are actually virtual disks now. But even though we actually see them as physical disks. So Windows Server 2016 enables storage spaces, tiering, and write-back caching. Okay, so if you don't understand what the term tiering means, it means there's different levels. Okay, we spoke about how in the last lesson how if you have a whole heap of data, you know that some data is just sitting there, not being used at all, or not used that much. You'll have other data that's actually being used quite often. And we have other data which needs to be really, really high performance, like virtual machine data. Okay, so basically, why store every data exactly the same way? Okay, so of the data that's not being used very much, it doesn't matter if they're on a high performance drive or low performance drive. Okay, so put them on the low performance drive. If we have data which is really being accessed quite often and is being used and multiple people are accessing it, maybe we shift that to the higher performance drives. And obviously, if we're running virtual machines on these storage server, then we need to have them on some of the highest performing drives. So this storage space tiering allows us to have different levels, different tiers of storage. Maybe right at the highest performance, we have solid state hard drives. Then we have some regular hard drives. Then we might have compressed files. Then we might even connect it to the cloud as a final really low access storage. So virtual disk configuration options. So that when we create a virtual disk, we can actually have a couple of these different layouts. Okay, we can have a simple layout, a three-way or a two-way or three-way mirror. So we should already know, and we could also have a parity layout. So in your assignment, you'll be asked to set up mirroring for your operating system hard drive of your domain controller. But on your storage server or on your file server, you'll be asked to create a parity layout. So we're not talking about RAID 5 in that situation in the assignment. We're talking about this parity layout. And just like we spoke about the other day, that the mirror protects it by basically storing it at least twice. The parity generates a parity bit, which actually allows us to calculate what the missing hard drive is if we do have a failure. So this still works in that way. The disk cluster size is a 512 or 512E, and the drive allocation can be automatic. So you can tell it to automatically select the drives that you have and allocate it accordingly. Or you can manually allocate the drives according to how you want to configure it. And then there's the idea of the hot spare, which actually is the hot spare is that it's basically saying that there's a hard drive there that's not actually being used right now. It's just sitting there. It's a spare drive. So if we had a parity volume and then parity layout, and then one of the hard drives that was part of that parity layout fails. Okay, if it fails, then it's no longer redundant, is it? But if we have this hot spare, it could actually just jump in because it's hot, meaning it's running. It's a spare, and you can jump in and provide that what's the redundancy again. So all the lost data will be reconstructed on this hot spare, and it will become redundant again. Okay. There's also the ideas of provisioning schemes. Okay. There's what's called fin provisioned or fixed provisioned. Okay. Basically, what does that mean? It's just like the idea when we actually create a virtual machine and we specify the hard drive. Remember, we can allocate disk space straight away, or we can allocate, we don't allocate disk space straight away. You remember that, guys, from the 4IVM subject? Okay, when you create a virtual machine, you can allocate disk space straight away or not. So basically, when we do fixed provision, it's like allocating disk space straight away. If you want a 60 gig volume or drive or disk, then you actually allocate that space straight away. It uses 60 gigs. Whereas fin provision is like not allocating this space straight away. You want a 60 gig disk, but you're really using only 10 gigs of it, you only use 10 gigs of it. And you only be allocated 10 gigs of it. And it will grow up to 60 gigs as opposed to having all the space provided to you straight away. And obviously there's reasons for why you would or won't need this. So obviously if you fix provision, you know that this space is already allocated to your drive disk and no one can take it away. But obviously if you have 5 departments and you've created 5 different disks and they're all fixed provision, in the sense that if we have 50 gigs and there's 5 departments, the sensible idea is to give them 10 gig each, isn't it? And if we do fixed provisioning, that they get 10 gigs each, and that's theirs. But the problem is, if we have these 5 departments, they might not use their data exactly the same. Store their data exactly the same. You might have a department that has lots and lots of data and is using all its capacity. You might have another department that might be only have a little bit of data and only uses like 1% or 10% of their capacity. So if you use fixed provisioning in that sense, everyone's going to get 10 gigs, but it turns out that you're really only using 25 gigs, but the department that needs the hard drive space is run out. Whereas you got this other 25 gigs somewhere sitting free because it's not being used by the other departments used. So in that situation, if we did fin provisioning and we just created 50 gigs, and we allocated 50 gigs to each of the departments, but because the space is not allocated straight away, what we can do is overcommit. Okay, so if the department needs a lot of space, what they'll do is they actually use up the space up to 50 gigs. Whereas another department may not need a lot of space, then they just use up their 1 or 2 gigs. And as a result, you are actually using up your space more efficiently. The people who needs it gets it. The people who don't needs it don't use it and don't waste it. So the management option for storage spaces. So the basic management for storage spaces is available through Server Manager. Okay, and for disk failures, we do not use check disk or scan disk. We just remove the drive, add a new one, and reactivate it. There's advanced management of the storage spaces using Windows PowerShell. Okay, like I've been mentioning, everything you can do with the GUI, you can do with the PowerShell. Then the next thing we're going to talk about is what we call offline files. Offline files allows your computer to cache network files locally for offline use. Okay, what does that mean? That means like if you've got a laptop, you're working on something that's on the L drive, okay, our network drive, and you're working on it, and you've clicked save, but now you had to go home. When you get home, you realize, hey, there was that little bit that I wasn't sure about, and now I know that was wrong. I want to go change that file. Well, you know, because it was on the L drive, if I'm at home, I can't connect to the L drive. So how can I edit that file? Okay, I can't. I don't even have that file locally on my computer because it was directly on the L drive that I'm using it from. So what this offline files allows us to do is actually allows us to cache those files that was on the network drive that you were accessing on your local computer. What does that mean? Temporarily store it. So in that situation where that person with the laptop went home, they'll open up their laptop, they'll log in, and they'll want to continue editing that file that they realized there was a mistake. They can just open it up from the L drive, even though they're not directly connected to the L drive anymore. But because it's cached, they'll be able to open that file they were editing before, make the changes, and then next time when they go back to the office, those changes will be updated to the L drive. Okay, so offline files allows client computers to cache network files locally for offline use when they are disconnected from network. And you can see from this picture, you can choose which files and programs, if any, are available to user when offline. So there's some things we can configure. So in this case, it's selected only files and programs that the users specify are offline. So this allows the user to manually choose what's cached. There's another option that says no files or programs from the shared folder are available. So this is not turning this off basically. Or you can choose this third option, all files and programs that users open from the share and folder are automatically available offline. So this is probably the situation that I was describing just before. If I'm using it, it's cached. I go home, realize I need to continue to use it. I don't have to work out how I'm going to get that file from the L drive to my computer now. It's cached. and I can continue to use it. Okay, it's really great for people who are on the go, mobile workers, which is basically everyone these days. Okay, there'll be hardly very few workers that only do their work on the work site. There'll be very few people that only do it on the work site and has a static computer that's the only computer they ever use for work. Then there's the idea of the shadow copy, guys. The shadow copy allows access to previous versions of files. Oh, what does that mean? Whoa. It means that what if I actually had a file last week, last Wednesday, let's say, and it was had the contents was not like this, and on Thursday I made some changes. I just went in, modified it, changed the contents of that file, and today I realized, oh shoot, those changes I made were wrong. I should have kept my original file. Okay, so what you can what shadow copy allows us to do, assuming that the shadow copy actually ran between when you had the original file and between when you made your changes, is that it actually sort of backs up those files and it tracks changes, which means that I can actually restore a previous version even though I've made changes or modified it. So shadow copy does not replace your backups. It's not a replacement for backups. I've got to make that for certain. Okay, but it's just another way to allow you to actually be able to get out of jail, just in case you're getting yourself in trouble like that. So let's see if we've got any like that set up on our drives here. Okay, so if I go to our L drive, cert diploma 5 ICW. Okay, let's see if we've got the shadow copy turned on here. So if I go to properties of this file, you can see there's a tab that says previous versions. And obviously, if you've configured your shadow copy to run at certain times, it will actually have previous versions. In this case, there's no previous versions. Let me see if on our S drive, if we have any previous versions. And we'll do this in the practical when we actually do it. So, all right, so still working on it. All right, let's get back to our PowerPoint anyway while that's working on it. So basically, I just showed you that from that tab, you can see any previous versions. And from that tab, you can actually restore those previous versions or open up those previous versions or copy those previous versions to another location. Okay, still not coming up with anything at the moment. Okay, so it allows access to previous version of your files. It's based on tracking disk changes. So disk space is allocated on the same volume. So when you do a shadow copy, you are using up more space. It's on the same volume of where the files are. When the space is full, the older shadow copies are removed. Okay, you don't have to worry about cleaning up space. It just automatically deletes the older copies. I heavily stress it is not a replacement for backups. And we'll learn more about backups in the future, but it's not a replacement for backups. And shadow copy is not suitable for recovering databases. Okay, databases are a lot more complex than just simple files. So it's not suitable for that. No previous versions, unfortunately, for me to show you. All right, so here's when we actually configure shadow copy, we can configure when it takes a shadow copy. It's almost like, it's not a snapshot, but it's almost like the idea of you taking a snapshot of your virtual machines, but it's not. Okay, it's a shadow copy of individual files. Okay, so if we look at the schedule, this is when it will run a shadow copy. So in this case, I've the default schedule is 7 a.m. and noon. And in this case, we can change the schedule. We can do it like every weekday by the looks of it. Yeah, at 7 a.m. and we can change this to what we want. So, for example, it doesn't specify Saturday and Sunday, but if our business operates on Saturday and Sunday, it's probably a good idea to actually take shadow copies on those days as well. So we can create a shadow copy schedule based on the capacity of the server, the frequency of the changes, and the importance of the changes. When we actually restore from shadow copy, previous versions are accessible from the properties dialog box of a file or folder. Administrators can restore previous versions directly on the server, but users can restore previous versions over the networks. So if you didn't understand that, it's actually quite an important thing to stress right this second, because it's not just an administrator task. Whoa, what does that mean? That means that, hey, you don't have to be an administrator to use this shadow copy. So you don't have to bug the administrator if you want to check something, if you want to do something. As a regular user, as long as you can access that file, you can actually restore that previous version over a network to your own computer and have a copy of that previous version. All users can restore a file or folder. All users can browse previous versions of select the correct one. All users can copy a file or folder to an alternate location, but the administrator can actually restore it directly on the server to the original location. So basically what this means is that all these users are capable of doing this for themselves. They don't need to bug the administrator, and they can quickly and simply look for the versions through the versions themselves, compare it, and the administrator doesn't even have to get involved. Okay, that's a good thing. You don't want to be sitting there as the user is checking through all the different versions, see which one's possibly correct. So work folders is another thing that Server 2016 can do. Okay, work folders basically allows us to have files and resources on our servers, but allows us to use devices. Okay, whether they be domain devices, computers and desktops. So they're part of the Active Directory domain. Obviously, that's pretty easy. We can use access resources in the domain, and that's pretty normal stuff. But what if we also have the idea of bring your own device, BYOD? Okay, so a lot of you guys might bring your laptops, your mobile phones to TAFE, okay, to work. But what if I want to access the same things, same files and so forth on these computers which are not members of the domain? They're your private devices, they're your private tablets, your private laptops, your private mobile phones. But through this, what's called a reverse proxy, we can actually access these resources through a HTTPS website. Okay, so basically HTTPS, it means it's secured, means it's encrypted, so no one can snoop your information as you are using it, but you can use it from pretty much anywhere. Okay, anywhere. If the ability, because it's based on HTTPS, we can actually mean that we could be on the go. We could be in Bali, sitting in an internet cafe, having a coffee, and still be accessing files and resources back at our site through this work folders and allowing us to do some work or to quickly do something that's really quick and important. So there's with work folders, there's security policies that enforce encryption, lock devices, and wipe corporate data off devices. Okay, so what if these devices get stolen because you're on that internet cafe, you left it behind? Okay, you could have some really, really highly sensitive information that you were using. So from the security policies, we can actually remotely wipe those information off those devices that were accessing it. File management techniques include quotas, file screens, reporting and classification. You'll learn more about this when you do the for AWS. But basically, essentially, quotas allow you to, limit the amount of how much people can store onto the networked drives. You know how it is. If everyone has open access to storing stuff, there'll be one person that will store a huge amount of data, and there'll be other people who hardly store any. And that doesn't seem fair if we run out of space, does it? So with the idea of quotas, we can actually implement that, hey, everyone gets, or everyone in the group gets a certain amount of storage. And that seems fair. So that one person or one department doesn't actually use up all the storage space unfairly. There's also file screens, and we all know that some files are big and some files are small, and some files are important for the whole workplace. Some things are just for your really personal use. So, for example, if we actually have ISOs as example, okay, we all know what ISOs are. They're the images of DVDs and CDs, but you know that some DVD images can be 4.5 gigs in size. Let's say we've got a Linux ISO that's the latest distribution of CentOS, and we've downloaded it as administrator and placed it on a special share for ISOs. But what if our other users, they might not know that we have a place that stores ISOs, and they actually download this ISO themselves, and they don't have space on their laptop, so they want to put it on a network drive, but they want to put it under their share. Well, that's just going to waste our spaces, isn't it? So we can use file screen to actually prevent people from storing certain types of files. It works by their file extension. So if you want to prevent people from storing ISO files on their department folders or their home directories, you can actually put a file screen with the star.iso extension. There's also reporting. So obviously, how do we know how much people are using of their system? Storage systems, we can actually create reports to actually identify the biggest files, the highest users of the system, and so forth. And classification allows us to classify certain types of files and perform some automatic actions on them. Some benefits and limitations of work folders. So benefits of work folders include you can work on domain joined devices and devices that are not domain joined. So if you don't understand that, that means obviously we all know how to join a computer to a domain by this stage. Okay, they're in the domain. But pretty much if we're talking about the TAFE-SA domain, the computers that are in the domain are pretty much owned by TAFE-SA. Okay, you can't bring your laptop home from home in and join the domain. They just won't let you. Okay, they won't let you join your personal device to the domain. So what this is saying is that you can still access the same resources that you can access from a domain joined computer with a non-domain joined computer from your personal device. It provides a single point of access for work files. It provides offline access to work files. It synchronizes files for users. It enables data encryption, and it works with existing data management technologies. Some limitations of work folders. It only works on Server 2006 and Windows 10 only. So it's a very new feature. So if your systems and your clients and your computers and your clients, your clients' devices are not Windows 10 or Server 2016, they can't use this feature. Okay. It does not support a collaborative scenario. This is not meant for you sharing work with each other. Okay, it's meant for you to be able to access resources that's on a central location. It's not giving other people access to your files on your computer. Okay, if you want to do that, there's other things like from Microsoft. There's the SharePoint. Okay, portal server. It does not permit selective synchronization of files. It does not synchronize multiple file shares. So there are some limitations, but overall it's pretty good. Some of the components of a work folder includes that you need to have a Server 2016 file server, you need to have Windows 10 clients, and you need to have SSL certificates. So if you don't know what SSL stands for, that stands for Secure Socket Layer. Remember how we said it was using HTTPS? That S stands for the Secure Socket Layer, and it actually protects the data through encryption. And the file system you need is NTFS or REFS volume for both the server and the client. On the server, you need to have the work folder role service installed. You need to have the file server role service installed. And obviously, because we're accessing it through HTTPS, we need the web server, the IS role installed. We also need the IS management console role service, as well as the IS hostable web course role service. On the client computers, we can manually deploy it using inbuilt control panel items, or we can automatically deploy using group policy, configuration manager, or Microsoft's Intune program. So these are different ways of deploying work folders onto the client machines. Okay, so on the server, it's probably all manual. it's all manual because you're the server you set up once. But when you have 2,000 clients, you don't necessarily want to set that up manually every time. So you can do it automatically through Group Policies, Configuration Manager, or Intune. Configuring work folders. So server configuration. Install the work folder role service, create a sync share, install the server certificates, which has the same common name as the work URL. On the client configuration, if we're doing manual, the user enters their email address manually. For automatic configuration, you can use Group Policies to automate that. All right, the next thing we're going to talk about is SMB and NFS. So last lesson we spoke about how these are two protocols for sharing files on the network. Okay, the protocol that we normally use on a Windows computer and when we share a folder like we've been doing is SMB, Server Message Block. Okay, sometimes it's called CIFS, Common Internet File System. And on Unix and Linux, the protocol they usually use is NFS. Okay, so NFS is a standardized file system protocol typically used by Linux and Unix. To create a NFS share, you must install this, the server for NFS role feature, and we can do this with Server Manager or with our PowerShell commands. Okay, so let me just quickly maybe show you creating a share. That's fairly straightforward. So right now, we've been creating shares the traditional way. And what does that mean? That means we go to a folder, we just right click on it, and we go to the sharing tab. But we can also do it through Server Manager. Okay, let me just quickly show you an example of this. So with Server Manager, we just spoke about how we can, in order to create NFS shares, we have to install the NFS server role. So we will actually go through this add, remove roles and features. And when we go to the file and storage server, here it is, server for NFS. We add the features, and we in here we've got a couple other things as well, and we'll look at some more of this in our worksheet. But just the NFS tool, okay, and it's going to install, and hopefully it does that pretty quickly. But once you've installed it, instead of actually creating a share by going to the folder and right-clicking and going to the sharing tab, what we can do is we can use Server Manager and create the share. And from there, we have a lot more options. We can choose the protocol, for example, SMB or NFS, and we can choose the type of SMB share because we can choose SMB versions. SMB free has a lot more features. So let me just quickly show you guys. So from the file system storage area, we can launch that. We can look at shares. And right now, there's already some shares that we've already created. But I can actually create a new share. And now we can actually create a SMB share quick, which is basically a basic share, just like the one we would create if we right-clicked on a folder and shared it. But we can also create what's called an advanced SMB share. And through this, we have a lot more options. And through this, we can actually set up the owners of this folder owners for access denied assistance, or configure default classification of data that's on the folder, or enable quotas in all the same go. There's also a third option for SMB shares, and this is where we can actually create an SMB free share that allows services such as Hyper-V and databases to actually store their data on these shares. What does this mean? If you don't know what Hyper-V is, for example, Hyper-V is a virtualization software that's from Microsoft. And what you guys have been doing so far is actually storing the virtual machines on the local hard drive of the computer you're doing the virtualization on. But when you create a share like this, you can actually store the files of the virtual machines, the virtual disk files, on this server, but actually virtualize it on another server. So we're giving ourselves what's called a central shared storage. But from here, we can also create a NFS share quick, which is the default simple settings, or actually you see some of the advanced features. Okay, so if I do quick, I might just go put on the C drive, and I'm gonna call it NFS underscore share. And if you look at this, this is even gives you a actually NFS path that you can use in your Linux machines. And obviously here we can actually talk about the authentication methods. Okay, we'll just use the Kerberos 5, and we can actually specify permissions. We can actually specify the host machine for a particular computer, a group computer, or we can just okay, we'll so in that case, we're saying that Windows 10 can access it. Here's the basic permissions, and we can customize these permissions like we've been talking about before, and we could just create. All right, something's failed, but let's not worry about that. But basically, that's how you create an NFS share or SMB share through Server Manager. And we'll be doing that in our worksheet to give you more in-depth. We'll look at it. So let's talk about storage pools. We already mentioned how storage pools allows us to disconnect disks from the volumes from the actual physical drive. So this virtualization called storage spaces can combine space from different physical disks and allocate it to create a virtual disk of any size. So we can have 5 10 gig hard drives, and so we have a pool of 50 gigs, but then out of that we can create 30 gig virtual disks, 20 gig virtual disks, and so forth. So it doesn't have to match up with anything that's physical. It's storage pools is often found in storage SANs or NASs. Okay, so basically what I said before was that this idea of storage spaces turns our Server 2016 into almost a storage server. Okay, instead of going off and buying a piece of hardware from a vendor that's specific for a SAN, we can actually make our servers 2016 with regular server hardware and turn it into a storage server, a SAN or NAS. Okay, it provides the similar capabilities to using standard DAS or external JBODs. So we know what a DAS is, that's a direct attached storage, but JBODs stands for just a bunch of disks, an array. So basically it's a chassis full of hard drives, and we can actually plug that into our Server 2016 and use these hard drives and make them into storage pools, then create virtual disk out of them, and then create volumes, and then out of that possibly create iSCSI targets or SMB free shares that allows for other computers to then use it. So storage spaces uses unallocated disk space to create storage pools. So basically it takes all the space that's available on the physical hard drives and combines it into a big pool. It doesn't matter where the space is or how the space is arranged. Underneath, there's you can create what's called a parity layout, mirroring layout, and all other types of layouts as well. But at the end of the day, you got the space, and then that's in the pool, and you create virtual disks how you see fit. Storage pools can span multiple drives. It can expand and reduce by adding or removing these disks from the pool. So, like for example, today I have 5 disks. I put them all in the pool. Tomorrow I realize, hey, I need more storage. I just buy another 5 disks and put them in the pool, and the pool suddenly grows. Okay. If some of my disks is getting to the end of life and I'm not really using them, I might just take them out of the pool and reduce the space. So it's gives us this flexibility. Like I said, it disconnects actual volumes from the physical disk. So we can do what we like with the physical disks behind the scenes, and the data is still just using this space in the pool as we are doing these. So it manages itself to coordinate the data. Storage, what's a virtual disk can be then created in these storage pools, and then these virtual disks is what we use to create our volumes in. Storage spaces features allows administrator to use higher performance storage devices for commonly used files. So this is getting that idea of tiered storage. So we can actually set up a tiered storage so that commonly used files or files that it needs to be that have high performance could be stored on SSDs, whereas less commonly used files might be stored on the normal regular hard drives. Okay, why is that? Because we all know that SSDs are more expensive. HDDs give you a lot more capacity and it's usually cheaper. So why store everything equally? We know not all files are equal. People don't use all files exactly the same way. So we store the highly accessed ones in the SSDs because people are using it. We store the ones that people are not used on the normal regular hard drives. Then create a virtual disk that includes space from both types of drives. Once user begins storing data on the virtual disk, the system will transparently copy. So what does that mean? Transparent means that without you knowing, without you actually needing to do anything, it does it for you behind the scenes. So basically, it is responsible for moving the data according to its usage, to whether it's in the fast storage or the slow storage, the expensive storage or the cheap storage. So behind the scenes is doing this for you. You don't need to worry about it. You don't physically manually move it from here to there. You just use it as you normally would use it, but the system would actually move the storage of the files to the different areas. iSCSI targets and initiators. So last session we talked about iSCSI. It's actually a protocol. It's basically the SCSI commands. So if you don't know what SCSI is, that's a small computer system interface. And basically in the past, SCSI is a way of connecting hard drives, internal hard drives, to server grade machines. Okay. iSCSI takes those same commands, but encapsulate it in a TCP/IP. Okay, in an IP network. Okay, so basically what does that mean? It means that, hey, instead of having those disks internal to our servers, they're actually sitting on another computer or another storage area network or something else elsewhere. And we're going to send those commands to read, to write, to perform actions through the TCP/IP network to those storage area networks. This makes, so basically this is another connection method that rivals the fiber channels. So basically if you don't have fiber optics in your networks and you're not comfortable working with fiber, you still can have a SAN, but instead of using fiber channels, you use iSCSI, which uses your normal everyday network. Okay, this makes iSCSI far more economical and practical solution because you don't have to learn a new skill. You don't have to fork out for all these specialized network cards and the devices which uses fiber. You can just use your regular Ethernet network and the network you already have. So it uses the same cables, the same network adapters, the same switches and routers for the SAN that you would use in the LAN. So it actually saves you money. Okay. But whereas if you want fiber channels, then you have to have a fiber optic fiber cards, fiber switches, all those kind of extra additions to your normal network that you wouldn't have already. With iSCSI, there's actually two parts of it. Okay, there's two parts of the iSCSI. There's what's called a target. Okay, that's like the server. There's an initiator, which is like the client. And basically the initiator connects to the target and they form a connection, and then the client or the computer that's using the storage sends information to the computer which is hosting the storage about what to write, what to read, and so forth. So iSCSI has two parts, initiators and targets. And iSCSI initiator initiates the iSCSI communication, and this can be hardware or software based. What does that mean? If it's hardware based, you buy a special card, network card, which is iSCSI for iSCSI, and it will actually do a lot of the work for you. Whereas if you don't have a special network card for iSCSI, you just use your typical normal network card, and then your operating system does all the work, which means your regular CPU and memory does all the work. On an iSCSI network, the initiator replaces the host adapter of its traditional SCSI use. The initiator receives requests from the operating system and sends it to the target. Hardware initiators is a host bus adapter, or HBA. It is an expansion card that is part of a SCSI host adapter and a gigabit network, Ethernet network combined together. The hardware-based ones obviously is better, but it costs you money because you need specialized cards. Whereas if you use software, it's just uses your normal cards. But the advantage of the hardware-based ones is if it offloads some of the iSCSI processing or SCSI processing, which means you don't have to use your actual system CPU and memory to do the work. The hardware card, iSCSI initiator card, will do the work. Software-based initiators connects to the storage device using a standard normal NIC, and obviously instead of actually the hardware doing the work, your software is doing the work, which in turn makes your actual system CPU and memory do all the work. iSCSI targets is a storage device or drive array. The target receives the commands from the initiators and then passes them to the storage device or LUN, or logical unit, that actually has the data. The LUN is an address that the SCSI device uses to identify a specific storage resource. A single LUN can represent an entire hard disk or part of a disk or part of a drive array. A single computer or drive array can have many LUNs represented by multiple targets. Targets can be implemented in the firmware or software in the form of a service or daemon. Windows Server 2016 includes the iSCSI target server role, and we'll do this in our worksheets again. We'll create an iSCSI target, and basically what this allows us to do is use other computers or servers to connect to these iSCSI targets through the network and treat them almost like internal disks. So you can have that centralized storage for virtualization. You can have, you can even boot from these iSCSI disks. So configuring INS, so Internet Storage Name Service. Okay, so it sounds a bit like DNS. In fact, it's very similar to DNS. Okay, it registers the presence of initiators or iSCSI initiators or targets. It responds from queries from INS clients, similar to DNS. And the INS consists of 4 components: a server, which receives and processes the registration and queries using the ISDNS database. There's the ISDNS database information, which is stored on the server, and then there's the client, which is a component of the iSCSI initiator and target to register information about itself and also query information about other servers. The ISNS protocol is used for registration and query traffic. All right, the next thing we're going to talk about is storage replicas. Okay, what's storage replica? You know that a replica is a copy, right? If I replicate something, I copy something. So what if we have a storage server here in Adelaide? That's great for Adelaide, great for the Adelaide campus. But if we have the files here at Adelaide, what about the Noarlunga campus? What about the Mount Gambier campus? If they want to access the same files because they're learning the same subject, how do they access those files? If they have to come all the way through the WAN to the Adelaide campus and access our storage servers here, it's very slow, isn't it? It's very slow comparatively. So if you think about it, on the LAN we have gigabit network at a minimum these days. But through the WAN, like even if you got a 100 meg connection, that's certainly a lot slower than the gigabit. And don't forget, that's a one individual 100 megabit connection, which means it's sharing that connection with every other type of traffic as well. Okay, so we can easily, it's a lot slower than on a LAN. So why don't we have a copy local on those campuses? Oh, that sounds a good idea. Why don't we have a copy at the Mount Gambier campus of the file server that we have here? Okay, but if we just did a manual copy, that copy can easily be out of date. So if we make a change today, then they'll be different over there if it's just a manual copy. So what storage replica does is that it can replicate volumes synchronously or asynchronously for disaster recovery preparedness or disaster recovery, or can be located on the same computer or distant cities. So this is really for replicating the data. Synchronous means at the same time. Okay, so something happened here, it immediately replicates over there. And you know what? That's going to be really slow if that connection is slow. So because if you do synchronous replication, data is written to two destinations at the same time before the acknowledgement of the IO requests to the originating application. So basically, this means that you won't be able to do the next thing unless it confirms that both destinations at least have written it successfully. What does that mean? That means if I'm really fast here in Adelaide because it's local, but it's really slow to Mount Gambier, it means I have to sit around, wait around until it gets done both locations. So that's not so good for slow connections. So so basically a synchronous replication, you need a fast connection and the data can be mirrored. The great thing about synchronous replication is because everything is done at the same time, if there is a outage, if there is like the one site, let's say the Adelaide site gets wiped out because the power went out and all our servers exploded. Okay, that's obviously a worst case scenario. But if that happens right now, and if we had synchronous replication, it means at Mount Gambier we have a exact copy of what happened to the second. Okay? No data is lost in the case of failure. As asynchronous replication, A means not synchronous, basically. Okay? A means not in general English language. So when it's asynchronous, it means not synchronous. So data is written to a single destination and acknowledged immediately, probably your local destination, the local site. And then it will behind the scenes replicate to the other site when it can. Okay? So with this one, the advantage is that I'm not waiting around because there's a slow connection between the two sites. I'm just doing my work like normal. Okay? So the data is written to a single destination and acknowledged immediately. Then it is replicated to the second destination with acknowledgement sent to the replication partner, but not to the original application. That generated the right request. So basically, the original application is not waiting around, waiting for confirmation. Okay, it can just keep on working. And obviously, it means that hey, this is it means that not all data might be replicated because it's waiting to be replicated in the background. And depending on how fast our connection is, it has to catch up. Okay, assuming we have some downtime in the middle after hours, it will eventually catch up when the network is free because we're not at work. Okay. But potentially, if you're 24/7 and you're constantly doing stuff and generating data, it potentially could never catch up. Okay, that's one of the possible downsides. I'm not saying that's probably likely, but most places has a down period. Okay, for example, TAFE is open from 9 a.m. to 9 p.m. basically, but between 9 p.m. and the 9 a.m. in the morning, no one's going to be using that traffic or connection, so it gets to catch up during that period. But so basically in this, while we use asynchronous replication, it's used if we have slow technology or it's over a long distance or using the WAN link. And that's going to be for most different when you have different sites. Okay. And the downside is because we're doing our work and we're not worrying about it being replicated straight away, that there's some things which are going to be replicated that may not have been replicated when a disaster hits. Okay, if a disaster hits right now and we've got like 500 megs of data that we've worked on and it hasn't replicated yet, that just means that if this Adelaide site gets hit by a storm and all the servers blows up, on the secondary site, Mount Gambier, because of asynchronous replication, we have a replication. We have another copy, but that copy may not be up to date to the exact moment. So no guarantee the data will be identical at any given time. Okay, it's fairly good, but it's not exact. So storage replica is designed to function in three primary scenarios: server-to-server replication between local or shared storage volumes on two standalone servers. Okay, so two standalone servers that could be on the same site. Okay, so basically, what does that mean? That means that if one of these servers fails, dies, this one can take over straight away, couldn't it? Okay, so it's almost like instead of mirroring hard drive, you're mirroring servers here. So this is on the same side. This is a fast connection, so this will be synchronous replication. It could also be cluster-to-cluster replication. What does that mean? So the clusters can be using storage spaces with a SAN and storage or shared SAS or storage spaces direct, and you can fail over one cluster to another cluster. So in this case, a cluster is multiple computers doing the same job. They're using the same data, and this data is replicated. So therefore, if this data fails, these machines can't use that data anymore. They can fail over to this other cluster. Okay. So if the previous one was just mirroring individual servers, this is like mirroring the cluster. Okay. And then there's for stretch cluster, which replicates between the storage devices in an asymmetric cluster. In a stretch cluster, the cluster nodes are divided between two sites, each with its own storage. The stretch cluster is the only one supported by storage replica that includes an automated failover capability. So instead of being on the same site like the previous two scenarios, these are on different sites. Okay, this could be in Adelaide, this could be Mount Gambier. Okay, this could be head office, could be a branch office. And if the head office gets hit by a natural disaster, like I've been sort of exaggerating, and all the servers blow up, then it can fail over directly to this other site. So therefore, if you have a business that's making heaps of money, but your site is down, well, you've got the secondary site that can still work and make you that money. All right, the next thing we're going to talk about is data deduplication. Okay, so we all should know what duplicates are. Okay, more than one copy of something. So I'll give you a example. Let's remember how we were talking about example before, where we actually people were downloading ISOs. Like we're all learning about Linux, and CentOS has just released a new version. You know what you guys would like to do? You guys probably want to download that new version, right? So you'll go off and download it. You'll go off and download it, and everyone in this room goes off and downloads that version of Linux as an ISO. And you know what you're likely to do is, because you probably don't have too much storage these days on your devices, you'll store it on your network drive. Okay? You know what? You'll download 4.5 gigs and you'll download 4.5 gigs, and everyone in this room would download 4.5 gigs for that DVD ISO and put it on their network drive. You might put it under your haste drive, which is your personal folder. You might put it on this area that you put it somewhere else on the storage drive, shared storage, and people will put it all over the place. Maybe there's no consistency, and no one actually has any idea what anyone else is doing. So what does that mean? So let's say there's 10 people in this classroom, just to make it simplified. That's 10 times 4.5 gigs. Okay, that's 45 gigs. Well, the exact same file that we're storing just 10 times. Well, if you look at all the IT students that's at TAFE, you're looking at almost 1,000 students. Well, if they go off and all download a copy of that Linux, okay, 1,000, that's what's it? 45,000 gigs. All right, that's a lot of space, isn't it? If they all want to save it to their network drive. And obviously, I'm exaggerating there with 1,000, but just even with the 10 people, that's 45 gigs for the same file. So data deduplication optimizes a volume by analyzing files and storing the redundant parts once. So what does that mean? That means that the data deduplication will go through the storage, it will scan for duplicates. So if you guys are all telling you've stored this ISO somewhere on the file system on the server, doesn't matter where, as long as it's on the same volume, it will scan through and work out that, oh, there's 10 copies of the same file. So rather than storing it 10 times, I will actually store it just once. And all you guys, your copies will point to this data. Okay, it doesn't mean the place where you put the file is going to move. It's going to still be wherever you put it, but where it's actually stored is in this one place. So when you open the ISO, it's going to refer to the data stored here. When another person opens it, it's going to refer to the data here. It's almost like that linking, okay? There's shortcuts and so forth, but it's not. So this increases the storage efficiency by upwards of 95%, depending on the type of data. Data deduplication conserves storage space by locating redundant data and storing it only one copy. So you don't have to find it. No one has to do anything about this. When we implement data deduplication, it's going to automatically go through your file system and scan it and find these duplicates. You don't have to identify the duplicates for this system. It finds it for you. So data deduplication improves on many other technologies by operating at the volume level, not the file level. So here's another scenario. So me as a lecturer, I'm going to email you a PowerPoint slide. Let's say it's 10 megs. There's 3 of you in this example, and we all make a copy. We all download the copy of the PowerPoint and store it onto our network drives. Now we have four of these files. Yeah, storing the same file again. You know what? If we had data deduplication, we only need to store it once. And if you think of every little email attachment or every little file that person could have or download, that's just gonna improve efficiency every time. Okay. Other scenarios include virtual desktop infrastructure. So therefore, what does this mean? It means that, hey, instead of virtualizing just servers, we can virtualize desktops. Okay, what does that mean? That means instead of having physical machines in front of you that has a CPU, memory, and lots of power, we're going to have servers where your instance of your a virtual machine is going to be running on, and you're just going to use a monitor, keyboard, mouse, and a device to connect to that instance. That can even be a tablet. It can be even a phone. It can be anything. But they're running on the server, and they're stored somewhere. So if there's, again, 10 of us and we all have a Windows 10 operating system, let me ask you, if there's 10 different computers all with Windows 10 installed on them, how much of their file system will be identical? Guys, how much? How much of their operating system for these different virtual machines will be identical if they're all Windows 10? Lots of it. Okay, pretty much lots of it. So in a virtualized environment, instead of storing Windows 10 virtual machine once here, once here, once there, we store it that many times, but with data deduplication, we actually only store that once. What about backups? Okay, so all these servers are storing backups and so forth, and we might have different versions. Like here at TAFE, every semester we actually take a copy of all the resources we made for that semester and we put it somewhere. And the next semester we make another backup and we put it somewhere else again. So, but a lot of those files from semester to semester doesn't actually change. Okay, this PowerPoint probably won't change for a semester or so, unless I find errors and update it. So therefore, if we're storing over and over and over again, we are just basically wasting our storage, aren't we? With data deduplication, even though we have different versions of it, where it's the same, it's going to eliminate the extra storage. So before data deduplication, you need lots and lots of disks to actually store your data because you're storing so many copies of it. So lots and lots of money. After data dedup, you need less space, less money, but still storing this data for all the people to use. So instead of me talking about it, let's actually get you to work on it. So work on your worksheet 6. Obviously, this presumes you've already done worksheet 5 to understand what we're doing in worksheet 6. So get on with that and contact me if you need any help.